Janaranjani ma'am,
Yes, ma'am.
I think we can start.
Janaranjani ma'am, your voice is breaking. We don't hear you. We don't hear you, ma'am. Ma'am, you are not audible. Please check. Marinal ma'am, is she audible?
No ma'am.
Yes, your voice is breaking, Jana ma'am. Please.
Am I audible, ma'am?
Still your voice is breaking, ma'am.
Now it's clear?
No. Still. And lots of disturbances, voice disturbances.
Yes, ma'am. Ma'am, am I audible?
Yes, now clear.
My privilege to serve as the master of ceremony for today's third day Atal FTP Faculty Development Program on AI and cybersecurity for the sustainable future, innovations in health, agriculture, and master cities, organized by the Departments of Computer Science with Cybersecurity and Biotechnology, Hindustan College of Arts and Science. We are delighted to have with us our eminent resource persons who will enlighten us on today's theme with their expertise. To begin the proceedings, I now invite Mrs. M. Flory Shobana, Assistant Professor, Department of Biotechnology, to deliver the welcome address.
Good evening to one and all present here. It gives me an immense pleasure to extend a warm welcome to each one of you on the third day of this 6-day online FTP on AI and cybersecurity for a sustainable future, innovations in health, agriculture, and smart cities, organized under the banner of Atal Academy. At the outset, I wish to express my heartfelt gratitude to our management for their constant encouragement and support in organizing such knowledge enriching programs. I also extend my sincere thanks to our respected principal sir for his continuous support. And I extend a warm welcome to our respected resource person, Mr. Tyagarajan Palanisamy sir, CEO and co-founder, LearnLake Coimbatore for the session 1, and Mr. Rajbabu Gunaseelan sir, CEO and co-founder, Cyberwall Singapore for the second session. I would also like to place a record of our appreciation of Dr. Marinal Ma'am, Associate Professor, Department of Computer Science with Cybersecurity, and Dr. Rajalakshmi Ma'am, Professor and Head Department of Biotechnology for their tireless efforts in meticulously planning and executing this FTP. A special word of welcome to the faculty participants from various institutions and my dear colleagues. Your enthusiastic participation over the past 2 days has set a vibrant academic tone for this program. We are delighted to have such an esteemed gathering of academicians and researchers with us, contributing to fruitful discussions and collaborative learning. Today, as we embark on the third day of our FTP, we look forward to insightful sessions from our expert resource persons who will enlighten us on the interdisciplinary applications of AI and cybersecurity in healthcare, agriculture, and smart cities innovations. These areas are not only relevant to our academic pursuits, but also hold immense potential to shape a sustainable and secure future for society. Once again, I extend a warm welcome to our distinguished guests, respected resource persons, fellow faculty members, and participants. Let us continue to engage, learn, and contribute meaningfully to this academic journey. Since our chief guest remains same as earlier, I will proceed directly without a formal introduction and move on to the main discussion. Now I hand over the session to Mr. Tyagarajan Palanisamy sir. Sir, please.
Thank you, ma'am. Good evening, everyone. I think you all
Good
have
evening, sir.
settled down. So as you know
So
that
one
from my
second, can we
yeah,
have
yeah,
the photo session now?
sure, sure.
May I request all the participants to switch on your videos? Yes. I would like a few more participants to switch on the videos, please. Can a few more, please, switch on the videos? Okay. Thank you. We can, sir, you can take over the session.
Thank you, ma'am. Okay. If you guys want, you can work on parallelly with me, because you know that from my previous session, most of my tools will be hands-on practices. So you guys have a system on, you can try this data parallelly with me. So today what we are going to see is we are actually going to extract some real data from Google Earth Engine. Have any of you tried to get data from such kind of because you know that Google has all the Google Earth is the one that has all the geological data, including population data, temperatures. They're actually recording everything. So, have you, any of you guys tried to get such real data from them? There is another possibility that we can get some data from our IMD. If we can officially request them, they can provide the data. But this is another source which is online, which is available freely to everyone, that we can get authentic data from Google itself. If anybody has tried this before, you can say yes or no. But uh, yeah, then I can move on to my presentation and the hands-on. Or if you guys do any research or try to get a real data, where do you actually get those data from? I want to know this. If for your research or for your project or anything, if you want to have a realistic data of weather data or rainfall data, where do you guys usually get it from? NCBI. It's a government-based organization, is it, ma'am? So the data, is it authentic? Okay. Okay, I will move on to my presentation on the hands-on. I will show a demo of how you can actually get real data from Google itself. It might be you cannot get the current data, but you can get last year's data, whatever has been updated so far. Okay, it's not like you can get a real-time data up to today from the Google, but you can get to last month or something. Okay. Let me start share the screen. Is it visible?
Yes, sir.
Yes, sir.
Okay, ma'am. So as I mentioned, this session will be completely. I will be focusing on getting the rainfall data. Okay, I'll be getting last 4 years data until 2024. Then what I will be doing is I will be doing some data cleanup and analysis part, and there is another cool tool called Data Wrapper. So I'll be using this tool for visualization. You would have used the Excel sheets to create charts, all that kind of stuff. But this tool, what it does is it creates visuals in map kind of like you can add your data in India map or world map. So your data can be represented in a map type of visual. Okay, so we'll be going through that. Before that, I will share some insights. So you guys know that the rainfall data actually is most critical for our agriculture, for water drinkage. Okay, it indirectly connects to multiple factors. Okay, so it does have a very critical impact on our. So based on the monsoon shift, because you know that current the climates and the weather is not predictable. It is changing every year. So if we know the past 2 or 3 years trend, we can actually predict for next 2 3 years when the monsoon shift actually might occur. So we can actually prepare our for our cultivation and everything else. We can actually prepare before. Okay. So we can even get the data from localized. So there are different levels of data we can get. We can get the entire world data, or we can get a country level data, or we can get a state level or a district level. So we can actually drill down to the even to the localized district level data. So this is what we'll be looking today. So the data authentication part, you need not be worried because you are actually getting the data from the Google Earth engine itself. So whatever the data has been stored inside the Google Earth, you are actually extracting the data outside. So the data can be a big data as well. But if it's a big data, it's very hard to visualize the data. So I'll be showing a demo with a very simple data set. Okay. So the data we are going to get today from the Google Earth Engine is the data set is called CHIRPS. Okay. So it's called Climate Hazards Group Infrared Precipitation with Station Data. Okay. So whatever the precipitation has been recorded, all these data has been recorded inside the satellite. The Google Earth Engine actually stores all these data. So quasi-global means it's a big data. It's almost like related to a global level data. Just it's not the entire global, but almost near to that. So that's what is called quasi. So the as I said, we can actually the data we are going to extract can depends on the level. So GAUL is actually geographical. Let me check the. I keep forgetting the term. It's a global administrative unit layer. Okay, it's actually established by the Food Organization from United Nations. Okay, they have actually established this term. So level 0 is actually world level data. Level 1 is like a country level data. Within India, we can get the data. India or any other country. Okay. If you go to level 2, then it further drills down into the state level and further into district level as well. Okay. So as I said, we are going to see a state level specific rainfall trend analysis we will be doing today. So it covers actually the rainfall data, whatever is recorded, it will be shown until 2024, which will be the latest year. So once 2024 ends, we can see the 2024-25 whole data as well. Once the next year comes, okay. The resolution data we are going to see is actually up to 5 kilometers. You can get the resolution when you drill down or zoom in. You can actually get the data approximately till 5 kilometers range. Okay, that is the data accuracy of this. So the key tools we'll be using today is Google Earth Engine. So this is the engine that actually used to get all the data analyzed, all the planetary data, geospatial data, all the data will be stored inside this engine. Okay. I think Google Colab, some of you must have used from computer science background. You guys must have used it. So it's a Python based IDE. So we'll be creating some Python codes and we'll be trying to visualize the data using Google Colab. This is a free tool. Then finally, whatever the data cleanup has been done, that data will be uploading to data wrapper and we will be visualizing the data in a map related manner. Okay. So the data wrapper is also a free tool. So I have shown the steps here. What we'll be doing is we'll be going to Google Earth Engine today. I'll be showing how to log in, how to create a project, and we'll be using ChatGPT to create a code that can extract data from Google Earth Engine. It's based on JavaScript. So these steps, why I have mentioned these steps particularly is that if you don't follow these steps, it will ask for a payment. It will ask for a billing information. It will ask for your credit card, all those information. But if you follow the steps I am showing today, you can use the engine for free. Okay. You just need to sign up as an Earth Engine trainer or a trainee. So I will be signing up as a trainer. You guys, when you are trying a demo, you can sign up as a trainer or a trainee. It depends on your wishes. Okay. It takes both the trainer and trainee profiles. Okay. Let me stop the slideshow. I'll be sharing my window, Chrome window instead, so that you guys can see the. So I'll be going to, you just search as Google. Is the window visible? Is it fine?
Yes, sir.
Yeah.
Yes,
Okay.
sir.
Okay. So I just search as Google Earth Engine. The link I have given in my presentation as well. You can use that link. Once you go into the Earth Engine, it will be like a website. Okay. Yeah, it will be slightly confusing if you are if you don't know where you are going actually. So the one thing you need to go inside is you go to platform. Okay. Platform, and there is a thing called as code editor. So this link I will be sharing to you guys as well. So definitely you need to log in with your Google ID. So instead of going to the Google Earth Engine homepage, you guys can directly go to this link as well. Okay, it will work. So that you don't need to be confused where you're going. So we are only going to see the code editor. So you are going to start a new project. As I given in the steps, I'm going to start a new project here. This is my official Google ID, so it is asking for a secondary authentication. For you guys, if you use personal Gmail ID, it won't ask. Okay. So once you start a new project, there is a commercial use as well. So if it's a big organization, they want a big data that has all the world level data. They can actually sign up for commercial use, and the data, all the data you can get from that. Okay, but for training purpose, we are going for non-commercial use. Okay, I'm going to click on get started from here. So there will be some questions. I'm saying that I'm not choosing my company. I'm just saying I'm not giving any organization for it, since I'm just trying it out for a non-commercial purpose. So I'm choosing individual research or non-commercial use. Okay. So the non-commercial use, it will allow you to go through. So whatever the data you are filling here, this is all mentioned for a demo only. So once you choose non-commercial, here it actually asks for my eligibility. Why it was asking me in this area for you guys, if you use your personal Gmail ID, it will ask, are you a Google trainer or a trainee, Google Earth Engine. So that one I will show as well. Okay. I have another Google ID. Let me share that screen. So this is a personal Google ID. So here the questions will be different. So when you use a personal ID, you can the project name will be by default. That location, let it be no nothing, no organization. Okay. So if you go to a personal ID, like here, the choices will be different. Okay. Since I was using my company ID, the choices were a little different. So I'm showcasing the personal as well. Okay. So I'm choosing other. So here you see the organization type, there is a Earth Engine trainer or a trainee. So you can choose that if you are using your personal Google ID. Okay. So for my company ID, it's not showing up. So I just show this for your reference. Okay. So let me switch back to the other window. So you just give next, and then since we choose non-commercial plan, it will allow us to go through. So it is asking me what are the things I'm going to use Earth Engine for. I just should choose everything.
Sir, your screen is not shared properly.
Okay, okay. Let me check. Is it visible, ma'am? Yeah. Now should be able to see.
Yes, yes, sir.
Okay. So you just give next, and then just choose everything that you are going to use Earth Engine for. And I'm just it is asking for all the fields whatever you are going to Earth Engine use apply Earth Engine for. I'm just randomly choosing something. So once you go to the end of the step, there will be a register function. Why we are registering here is we are going to enable the Earth Engine API. So without this enable part, the code editor, you can't get the data from the Earth Engine. So if you register for non-commercial use, if you register successfully, then you can enable the API. So this is the main thing that we are going through. So without this API part, if you paste your code into the code editor, it won't work. Okay. So I'm going to enable. So after you have enabled, you go to the overview option, and there will be a code editor option here. You click on that, and your code editor will be open for the project just now we have created. Whatever the pop-ups coming in, you just close everything. So our actually the code whatever the code we are going to generate, we are going to paste it in the window here, the script window here. This is the code editor of Google Earth Engine. So let me go to my chat GPT. Let me share my entire screen so that so if you go to my PPT, the prompt I have given here, the prompt which I am going to use in my chat GPT. Okay. So I will just copy this prompt, and I'm going to chat GPT. Okay. Any window. You can create a new chat as well. So I'm just pasting my code here. The code, I will just explain the code. So I'm asking the ChatGPT to create the Google Earth Engine script, okay, that calculates the average rainfall for each Indian state from 2020 to 2024 using the CHIRPS dataset. Just now I shared the CHIRPS. Okay, it's a precipitation data. The script should there are two options I'm asking to the Google Earth Engine to generate. To visualize in the Google Earth Engine itself for the rainfall data for last year, 2024. And I want data to be extracted from Earth Engine itself, just the annual rainfall for each state from 2020 to 2024. Okay. So I'm just adding a one more sentence. Sorry. Let me stop it. You can always stop the generation part using the stop button. Then you can go back to the prompt again. You just click on the edit message. I'm asking it to simplify. Simple data set is enough for me. Actually, I don't want geological coordinates, because geological coordinates, then it will be a big data. It will be difficult for me to visualize. But if your guys are using some other uh, big data analysis, then you can just uh, don't give a simple data set. Then it will give a big data. Okay, simple data set with annual rainfall for each state is fine. Geo coordinates are not needed. Okay. Why I'm giving this is, uh, if I bluntly give without any simple data set, it will create a very big data set. Okay. So I'm adding an extra line here that to create a simple data set using Google Earth Engine script code. Then let me copy this prompt. You guys also can try I will give the prompt here, or you can get from my PPT as well. I think most of you would have created codes in ChatGPT and run it, created website kind of codes, everything you would have tried before, right? So it's the same principle. So the code has been created. I'm just simply going to copy this code, and I'm going to my Earth Engine code editor, and I'm just pasting the code here. Okay. Then as usual, you're going to run the code. Let the code run. So you can start to see that actually it zoomed into India map. Okay. Then you see that there are data loading here, layers are loading here. So I can see the heat map kind of map being generated, because I asked for two things, right? I asked to visualize the data, then I wanted to export data as well. So the visualize part is coming here. I can minimize this part. So this actually works like a Google Map interface. You can zoom in, then the layer, then the colors will get updated again. So whatever the red areas that you are seeing here is actually high rainfall regions. Okay, so you can see some clusters in between. Those are in the mid yellow, right? So it's like a mid to high range kind of rainfalls. So if you want, you can turn off the state boundaries. Okay, this is only for 2024. If you want to have for more years data, you can give in the code, and then you can change the for like 10 years. You want the data for 10 years, you can show as well. If you want to change the color, you can go to the settings here. I don't want the blue color shade. You can actually change that shade to something else. Okay, for your visualization part, if you want to, uh, like if this is a mid-range kind of thing, these are lower regions, right? So I can show us a lighter color. So in mid region, I can go to the same kind of maybe a bit darker. So the extreme, let it be red. Okay, is it fine now? This is just a visualization part. You can actually take a print screen and then uh, use this image. Okay, this is the authentic data from Google Earth Engine. Whatever the satellite imagery has been recording over the past year, it is collecting all the data and it's visualizing the map data file. Have any of you tried this with me? If not, then I will go to the next part. So the next part is we are going to extract the data as I mentioned, right? So where we can extract the data is you go to the right end of the menu here. The extreme window has something called as tasks here. Okay, let me expand it. So there is an unsubmitted task here that the data is with Earth Engine. I'm going to actually run this task to extract the data. So since this is a Google product, you can actually it can extract the data directly to your Google Drive. There is no option to extract the data to your local computer. So you can only extract the data to your Google Drive in these formats only. Okay. The closest we can use for analysis is CSV. We can change it to Excel easily. So I choose a CSV format. If you want, you can give a drive folder name. It will add the data to the folder. Or if you don't give any name, it will directly add data to your root folder. It's the main folder in your drive. It will directly add the data to your Google Drive. So I'm going to run this data. So you can see here that is the data is actually running. Once it has completed, there will be tick mark here. Then I can get the data from my Google Drive. Okay. Since I asked for a very simple data set, it took a very like 10 seconds. It extracted the data actually. So I'm going to my drive. So in your drive, just go to your home. Okay. In your home, you can see the data. Just now it was created. So I can see, it guys can see the data, right? So it's a state, year, and the average rainfall in. So because I asked for the data in millimeters. Okay. So for every year, the state's data has been populated until 2024. So this is the data I wanted. I'm going to download this data. So I got the data in my computer. Okay. So this data is kind of messy. Okay. The states keep repeating. The states and years are repeating actually. So is it fine until now? So we have did the most complex part. Then the next parts will be mostly you should have guys seen those steps actually. We are going to collab and then do some data cleanup and creating some pivot tables, all those things. Okay. Is it fine? Are you guys following till now, or is there any difficulty? Is it fine? I don't see any responses. Anybody has tried this before? Okay. So you go to this Earth, uh, the Earth engine. Let me share my. I will go to the next steps. Since okay, maybe a bit complex because, but there is no other way. So how you know that there is only two ways. You can get the data from actual government sources, or as I said, these data are actually available online for free. So that's what I'm showcasing here. Okay. So you can give credit to uh, Google Earth Engine whenever you're presenting the data. They may ask that where do you get this data from? So it's from Google Earth Engine satellite data from GAUL level 1 or level 2 or level 0. So it's authenticated data. Now I am going to the next step where we will be. I have even given you guys the code sample here. Okay, it's stored in GitHub. So whatever the code that ChatGPT has generated, it's available here. I'll give the link. You can go to the main folder, the climate smart data monitoring. It has all the G codes here. Okay. If you want to run in the code editor directly, you don't want to create the code using ChatGPT, you can use this one. So even the sample data, whatever the data I have extracted before, I have stored in my GitHub. So you can use that CSV data as well. To if you want to go to the next step in the Google Colab, you can directly take my CSV and then do the next steps. Okay. So next I will go to I will use this prompt. Okay. This is a bit more complex. So I'm going to create a Python script that actually reads my CSV file. I'm going to upload my CSV file that includes state, year, and average rainfall. That is what the data I'm having right now. So what I want it to do is I want to plot a trend chart. Okay, line chart for year versus rainfall. These are libraries. Okay, these are Seaborn and Matplot library is a type of library for plotting the charts. Okay, then I want to identify the top 5 states with the largest change in rainfall for last 4 years, and then plot them separately in a graph. And finally, I want to create a clean summary. I want to create a pivot table for the all the 4 years average rainfall for each state. So the cleaned up data will look like there will be an example like Tamil Nadu. The average rainfall will be for 4 years in consolidated 4 years average rainfall. Okay. So that data I needed to visualize in data wrapper. So the last one I can actually remove since I don't have any geo mapping. You can just leave it as it is. It won't do any harm. Okay. I'm just creating a Google Colab code using this prompt. Not giving the full. Is there character limitation in the chat? Okay, maybe that's what it is. You can get the prompt from my presentation. Okay. So the code that I have generated just now, I'm going to copy that code. So I think most of you have used Google Colab before, right? So this is a Python IDE. So you can run and visualize all the Python codes here. You want to see complex data. So once you go in, you can get a new notebook. It will automatically create a notebook in your Google Drive, Colab notebook. Okay, so it has created a Colab notebook here. I can rename the file as I am giving some name to it. Then I am just pasting my code here. Okay. Then let it run. If the code runs successfully, I should see a file upload button coming up. Then once I uploaded the file, then it should generate the visualizations and create a CSV file at the end. Okay. Okay. Now it's asking for me to upload the file. That file I just now I got from Google Earth Engine. I'm going to upload that file here. So it now I think I will use my old data, the one I extracted previously. Because my prompt, the prompt, the prompt I have generated is for my old data. Okay. Okay. The code itself is giving some errors. Now, man, I have the easiest way is to solve these errors is you just give the error code in the chat GPT, then it will resolve the error for you. But we don't have the time to resolve the error here. So I have the backup code in my GitHub. Okay. I will get the backup code. And I'm creating a new code window here, and I'm running the code I have generated before. This one I have verified, so it will work. Okay. So it has because I asked for data. I asked for data for data wrapper visualization as well. So the download also has happened. So once I run the code, all these things happen simultaneously. Okay. Here are the graphs it has plotted. So whatever the visualizations I have asked, the rainfall trends for all states. So the top for the last 4 years for all the states based on the color, it has color coded based on the states. And the top 5 states I have asked with the highest rainfall change. Okay. So it's Tripura, Goa, Mizoram, Bihar, and Manipur. So mostly it will be northeastern region. Okay. It will be north towards or it can be a coastal region on our western side as well. Then I asked for a CSV file, so it has been downloaded as well. You can see there are two CSV files here. So I asked for a 2024. Okay. So this is a pivot table. It has created a pivot table for me. So for each state, it has taken average for all the last 4 years, and it has given me the average. So this is the data I need to go to data wrapper to visualize in a map. Indian map. Okay. Is it fine? Okay. Voice. Sorry. Is it fine now, ma'am? I will raise my voice. Okay, the next, so the visualization part is a bit difficult. The tool I'm going to show you guys here is there are two advantages of using this tool. One thing is you can visualize in a map way, in a map as a pictorial way. Then another thing is you can get the embed code of this chart. Okay, the map visual, it can be created as an iframe code which you can embed into your college website or your research paper as well. If you are showcasing your research paper in a web page or something, you can actually embed the code in your HTML code. It will show as an interactive map. Okay. So I will show you the steps. This tool will take around 15 to 20 minutes. That's why I'm hurrying up to show the tool. Okay. Go to datawrapper.de, or you can search as data wrapper in Google. Has anyone used this tool before? I want to know if anybody is aware of this tool. If you guys don't have this data, even if you have some other Indian states data or a sample data, you can actually visualize using this tool. Okay. You can log in with your Google ID. Once you log in, there will be something called as dashboard. Okay. You go to dashboard. So as I said, this is the data visual application. It's the AI tool. It only works on data visualization part. It doesn't do analytics. But the feature it has is you have chart feature, but we are already using Excel to plot the charts. Whatever our requirement right now is to show the data in a map pattern. Okay. So I'm going to map. So I'm creating a new map. If let me minimize this. So you can see here, once I go into the map, there are three types of map here. One is something kind of color coded map. Second one is a bubble. This is like a bubble chart, right? So the last one is a navigator or a Google map type of mapping. So the sample I'm going to show here is it's called Chloroplug map, that you can actually show data based on the color codes. Okay. I'm just clicking on this visualization. You need some raw data to actually visualize in this tool. So there are two options. You can actually, by default, it's showing the world map. If you have a world level data of different countries data, you can use this data. Okay. But for us, the data just now I have created what it has. It only has Indian state data, right? It doesn't have world data. So I need to choose a India level data. So I just search India, then space states. Okay. So there are even the same map states and union territories. There are two maps available with the data wrapper community. Okay. They have the latest data until 2020, But if you guys need a latest data like 2025, you can actually upload your own map, but the condition should be it should be available in these two formats only, either topological JSON format or a geological JSON format. These two files are only supported. It will have coordinates inside. So that data they need. And the secondary one is the file size of the JSON file should not exceed 2 MB. Then you can actually upload your own map here. So right now I'm choosing the inbuilt map itself. I'm choosing the 2020 map. Okay. So this is what the map data wrapper map actually looks like. It may have some variations. We know that there are some union territories created recently. They might not have the data here. Okay. But to show us a demo, I will just proceed. Okay. So going to the next step, you just click proceed. So now it asks for a data. So once I scroll down, I can actually upload my data here. So the data just now I've created from Google Colab. I'm going to upload it here. So initially there will be some errors because the error happens because the data wrapper, the map they have created, the Andaman and Nicobar, there are some spelling differences. So it shows that my data, the spelling is this one, but the data wrapper community, the spelling is somewhat different. Okay, so it's throwing an error. The only thing I need to do here is I just choose the data wrapper name itself to resolve that error. So without resolving this error, you cannot proceed to the next step. So since we are mapping based on the state names, if the state names are exactly correct, then the mapping will work. Okay. So whatever the errors are thrown here, I need to correct all of them. Here you can see that actually Dadra Nagar and Daman and Dayu, they have everything as a single row, but my data has two rows here. Never mind, I'm just choosing I'm actually showing both. Let that be two data, or I can actually delete one set of data. Since we are just showing the demo here, you can double click on the cell and then there will be a delete option there. Okay, so I will resolve this error as well. Then Orissa is it's actually Odisha now. So my state data has been mapped to data wrapper namings, and my average rainfall data is recorded here. So all my data is clean so far. Okay. So you just scroll down to the bottom and click proceed. So the matching keys has been done. Okay, the name has been matched, and these two on the column average rainfall has been added. So this is just for a verification. Click on proceed again. There is some warnings. It says that 3 entries of this map are not in use. This will be grayed out in the map. So the whatever the data I have extracted from Google Earth Engine, sorry, from Google Colab doesn't have this Jammu Kashmir, Ladakh and Telangana data. So maybe this data is missing in my data set. Okay, let it be there, let it be grayed out. Okay, this is just a warning. It will allow me to proceed. Only the errors you cannot proceed. The warnings we can proceed to the next step. So you can see that the Jammu and Ladakh has been grayed out here, and the Telangana also has been grayed out. Let it be. If we have this data, we can manually fill it up as well. Go to the add data part, and you can actually fill it up manually as well. Okay. You can clean up in the CSV data and upload it again. So we have come to the middle part of the visualization in data wrapper. You can the colors are actually based on the rainfall indices. I don't want to be based on the rainfall. The color should be based on the state level. Okay, so I can easily identify which state is which color. Okay, I'm changing the column to state, and the palette I'm choosing the one with the largest variety of colors. Even if I choose a palette, some states will still be grayed out because there are too many states. It doesn't know which color to allocate to which state. We can manually change those. We can manually change those state colors from gray to some other shades because the palette only has this much fixed colors. So I'm going to Karnataka. I'm choosing a brighter orange color. So this way I can add colors to is Tamil Nadu color. So Tamil Nadu is not color. I can color Tamil Nadu. So I saw some green, kind of dark green. So this is all styling parts. Okay, this is all styling parts. If you guys have a sample data of India states or Tamil Nadu district-wise state data or global level data, country-wise data you have, you can use this tool for visualization. Okay, it's not only meant for this visualization. You can use for any kind of data. So all the styling parts, legends to the legend. What is the legend about? I can show the legend as state here. Enable highlighting on hover is whenever I hover over a certain region, the legend gets updated here. It gets highlighted here. So I know that I'm hovering over Uttar Pradesh region. Then there are some interesting features like you can even make the map zoomable. And the insert map, what it is actually is, let me minimize the screen. If actually I zoom into a certain part, I don't know actually which state I am actually current or which region of India I am currently at. So the insert map is the one mini version here. It shows actually where I am at. Okay. You can see some maps, you can see that you are here. They are mentioned like you are here, right? So that functionality is insert map. So I'm turning all these options up. I am enabling all these options. So the appearance, let it be. If you want, you can reset the zoom part. If you want, you can even hide the region borders as well. Let the region borders be visible. I don't want to change the alignment or map height, all those things I can change later. Okay. So this is all the styling part is coming under refine. There is a refine tab here. So if I go to annotate, I can actually add chart title here. Okay. So India rainfall data by states for 2020 to 2024. I can even mention average rainfall data. So the description you can give as well. You don't need description. Data source, where do you actually get the data source from? You can mention here. So you're kind of giving the credit to Google Earth Engine. Where did you actually get this data from? Okay. So the Google Earth Engine, I can give the Google Earth Engine link in this data wrapper. The link to the data source here. So what it actually does is it will add a footer here. It will show the source as Google Earth Engine, which will be a clickable link. Once I click on it, it will navigate to the Google Earth Engine page. So I'm adding it here. So another thing is you can actually show the labels. What label you want to show here? I have color coded the state data here. The only other data I can show is by column by average rainfall data. So the average rainfall numbers I can show here. I can round it off, or I can show the exact value as well. Okay. So the map label, show label is actually under the annotate tab. Okay. If you want to highlight some certain, if it's a very high rainfall recorded, you can actually highlight that portion. Okay. So what it is, if you this actually is whenever even even I zoom into the map, it actually the highest value actually sticks on. So that is what it actually does. We don't need this feature actually. Okay, rainfall data. Okay. Then the final part is something called as tooltips. So this tooltip, what is actually the technical term for this one is whenever you hover over a certain region in your map, whatever the text box is coming near the your cursor arrow, it is called as tooltip. You can actually customize that tooltip as well. Okay. Right now it is showing region and region, right? I don't want the region and region. The first one can be the state, like a region, Madhya Pradesh is okay. But the value I can show is instead of the region, I can show the average rainfall. Okay. But you don't know what is this number actually. Maybe you can read it from the chart header, but whenever you hover, you don't know what it actually does it mean, the number. So you can manually give a text here. Okay, average rainfall. I will remove the 2020, 2024. So I will remove the 2020, 2024. So right now you can see maybe the decimal point is too many. I can show to a single point. So I can see the so I can see the average rainfall whenever I hover over a region. I can see the average rainfall actually. Okay, is it fine so far? Am I audible? Do I need to raise my voice because
Audible, sir.
Audible, sir.
okay.
Audible, sir.
Okay, ma'am. So coming to the final part, we're going to the layout tab. Okay. So it has some other features as well. In the footer, there are some options like you can enable an image download option. You can enable the embed link. This is what the embed link is going to generate a iframe code for us. Then the another one interesting feature is you can actually enable the social media share buttons as well. So when you go and see on the top right hand, you can see all there are three social media buttons enabled here: Facebook, LinkedIn, and X. Okay. So we are enabling all these options in the layout tab. Then you are going to the final part. Either you can click proceed here or you can directly go to the top. There is a different tabs here. You can directly click on publish and embed. So the final part is you need to publish your visualization in the data wrapper community so that you can get the embed link code and everything else. Okay, so once you have published, or if you are going back and doing some changes again, then you need to republish again so that the map gets updated. Okay, so the first thing is you can share your data wrapper map to anyone. The link will be created. Then as I said, the embed link has been created here. So the responsive iframe is something like it will be responsive even if you open in your mobile screen or laptop screen. It will adapt according to your laptop or mobile screen dimensions. But I'm going with the default iframe. Okay. The default option, let it be. So the embed code is the code is actually here. You can click on the copy part here. Okay. So the code, I have copied the code. If you want to see the visualization part, how the code is actually going to be like in your website, there are two options. Either you can go to some online HTML IDE tools. This is one of the tool. It's called Code Pen. Okay, where you can see where you can see your HTML codes to visualize how your code actually works. So you just click on Start Coding. Then you just paste your, let me copy the code again. So I have not given anything here. I have just pasted a iframe code here. It's actually getting the visualization from the data wrapper, the share, whatever the visualization, it has a link here. So it's getting the source directly from the data wrapper. That is why you are publishing the data. So this is a chart actually. If you embed the code into your website, it will look like this. So all those hover function, the tooltip, zoomable part, the insert map, everything will work, including your download image part. So if you click on your download image, the chart image will be downloaded as a PNG because the default option was given was PNG. And finally, if you want to post this visualization in your, let's say example, LinkedIn, because I have already connected my LinkedIn in my profile here. I have logged into my, I have always kept it open. So it directly goes to my LinkedIn profile. So you can see that it is actually linked to my data wrapper visualization. Then I can give my thoughts here and I can just post the data. So we have actually created an authentic data and we did some cleanup and we created some summarize average data. We calculated the average data 4 years. Then we extracted the data from Google Colab. Then we came into data wrapper. Then we visualized the data as an Indian map. Okay. This is what the steps we have done. Is there any doubts in this? Or if you want, if you have any ideas of visualizing your own data, you can ask me. Okay. If you want to know some other, if you have your own data, if you have any doubts on that, you can ask me. Have any of you used this tool before, Data Wrapper?
Sir, this is Dr. Rajalakshmi here.
Yeah,
I
yeah,
have
yeah.
a doubt. So all these data are already available in Google Earth. You mentioned that. So,
Yes, yes, yes.
So this can it be used for prediction
Yes,
for the future?
the final part I will show a prediction as well. So yes, we can definitely use it for prediction because you can even get some approximate data from Perplexity uh, or ChatGPT. They will actually add a disclaimer at the end saying that the data might be rounded off, right? So it might be rounded off to an extreme that we don't know. Actually, it might be 50-50 data. We don't know. So if we get from Earth Engine, it may be. I won't say it may match 100% to our government data or IMD data, but it might match to this will be like a 80 to 90% matchable data. Okay, but you do have authentic data, right? Because it's collected by Google Earth based on satellite imagery, which is the data we are relying on for our weather forecast, all these things, right? So
But the prediction level will not be.
the prediction level will depend on your what kind of model you are going to use. Okay,
Okay.
yeah. Because I gave a simple data set here
Hmm.
with only rainfall data as
Rainfall
average.
data.
Yeah. If I didn't give a simple data set, you can remove that prompt simple data set, and if you extract the data from Earth Engine, it will be really a big data.
Okay.
Yeah, it will be very hard to read. It will take a lot of time to clean up the data. That's why I didn't show that. You can use my old prompt from my presentation, ma'am. You can use that prompt. It will create a big data for you. Okay, I will give the prompt here. If you use this prompt by default, because I have not mentioned here to generate a simple data set here, so it will by default it will create a big data set.
So for real-time data analysis,
Real-time
these
data analysis, this might not be
use helpful.
useful. Yeah,
Okay.
yeah, yeah,
Okay, sir.
yeah.
Thank you, sir.
Sure, ma'am. So the final part is I can because I have a time data like 4 years data. I can actually use this data for visualization as well. So I you can create a code using this again using a Colab Python script to create a code. So the model initially the model you can use is a linear regression, which is just a very simple model. This might not be a very accurate model. So if you want a more advanced type of prediction, you can use these models like ARIMA or ARIMA. I came across was somewhat better. Okay, but the prediction model depends actually on your data set, based on your data set. Okay, if your data set varies, the type of prediction model also will vary. You might need to try different prediction models uh, to match with the actual data. Like you can predict using 2023 data for 2024 and match it with an actual 2024 data. Which one is the closest match? You can choose that model and you can predict for the next 2 years. That is what you can do. Okay. So I have given a prompt exam sample for this model and a code sample as well. So I will run that ARIMA code sample directly. So if you go to my GitHub, So the GARIMA forecast prompt is available here. I've given the prompt here. Can copy this text and use ChatGPT to create the collab code, or you can directly use the ARIMA forecast code. Okay. Just copying this code, going to my collab. I'm creating a new code and then running this data. The upload option, you can keep it or you can remove. Okay. Since you already have the data inside, if there is a data existing inside, you can remove the upload option. The reason why I kept the upload option active is the data set might be changing as well. So this option always gives a flexibility for us. So it is creating based on ARIMA and some anomaly. It's actually predicting the top five. Usually the because it's the same states as 25, so it may change. Okay, so we need to see 2026 how it will be actually, or you need to do some deep research based on current 2025. There may be outliers as well, but this one you can keep as a reference for you. Okay, this is we are predicting based on actual data, so it will be somewhat the top 2 or 3 states might come up next year as well. Okay, based on this data, we don't want 100% accuracy. Even 60 to 70% accuracy is actually better for prediction. That is considered itself is a very good match. So this is a cluster data, bar cluster for based on different years. It is color coded. So prediction also we can do, but you need to try out different models. It will vary based on your data set as well. We can use my GitHub link to get all those codes directly, and then if there is no data extracted from your Google Earth Engine, you can use my data set for your for to use in Google Column and Data Wrapper as well. Okay. If there is any difficulty in signing up to the Google Earth Engine code editor, you can let me or Marina ma'am know, so I can assist on that. Okay. Any questions other than any other questions? You can try Data Wrapper. It's a wonderful tool for visualization of map kind of visualizations. I think I prefer Data Wrapper. But the only constraint is you don't have the latest map. If you have the data in the internet, if somebody has uploaded in the Git and is available, you can, like example, if you want, I can search in the Google engine, Indian states and union territories GeoJSON file. Okay, this is what I want. If somebody has uploaded it and if it's available, then you can actually use that. So this data is actually available. Somebody has uploaded the India JSON file 5 years ago. So this old data as well. I don't have any latest. This is just a JSON. we can actually create the GeoJSON, but we need to do some complex codings to it to get that data. So if it's available, you can upload the data and get the latest visualization. Okay. Any questions? If not, we can move on to the next one. Marina, ma'am, is it can we move on to the next session, or anybody else has any questions?
Yes, participants, do we have any questions? Actually, the session was interesting, sir, but we need some time to work and see because
Sure, ma'am. Sure. I think the most complex part is you're getting the data from the Earth engine. So you guys try it out.
Okay.
You know, I will always be available. I can assist on that. You can contact me anytime.
Sure.
Sure. GitHub data. I will share again the data.
Thank you, sir. Thank you for your insightful session, sir. Moving on, we now step into our second session of the day to be delivered by
Just a
Mr.
minute.
Raj Babu.
Janarajni, ma'am.
Yes, ma'am.
Just a minute.
Okay, ma'am.
Yeah. Participants, one small kind request. The feedback link for the first session is posted in the chat window. I would request everyone to give your feedbacks. We'll wait for 5 minutes because beyond that, we will not be sharing the link. I request all the participants to give the feedback in the link that is posted in the chat window. Raj Babu sir, just give it 2 minutes.
No problem, ma'am. No problem.
Yeah. Yes, Janarajni, ma'am, you can start.
Thank you, ma'am. Thank you, sir, for your valuable details on data interpretation using Google Colab and data production techniques. Thank you for the insightful session, sir. Moving on, we now step into our second section of the day to be delivered by Mr. Rajababu Gunasilan, CEO and founder of CyberVault Singapore. He will enlighten us with his expertise on global perspectives in AI and cybersecurity. We are honored to welcome you, sir. The virtual stage is now yours.
Thank you, Janarajani. Good evening, everyone. So yesterday we saw at a length about the impact of AI in healthcare, how AI helps to transform medical assistance and then curate on the patient's data and deliver a personalized healthcare. How a remote medical telemedicine or a medical assistance is going to be evolving in the coming future, and then we also talk about the data bias, which we need to handle at large. And we also saw about the HIPAA regulations and global data protection rights. That will be some of those challenges in implementing cybersecurity solutions for AI in healthcare. Today, my topic is a similar topic, but it is going to touch upon the agricultural sector. I'm not an agricultural area specialist, but I will try to deliver a session based on our expertise in the areas of cybersecurity and artificial intelligence. To give a perspective, like agriculture is probably one of the oldest industry, at least in India, where 50 to 70 percentage of the occupational is based on agriculture, and it has been our I mean, like has been our core food generating engine, not only for India but also for all over the world. So basically, what we are going to, sorry, there is some question. Okay, I will come to those question and sessions at the end of the session. If you could allow me to proceed with this session, so we will talk about the challenges and other things at the end of the session. Maybe I will share my slides. Can you guys see my screen?
No,
Can you
sir.
guys?
No, no,
No, is it?
no.
Oh, okay, okay.
Yeah, now it's visible.
Okay. Okay, so today we are going to touch upon the topics of introduction to agrotech, how the current agricultural trend is evolving with the new technology landscape, how smaller, even smaller players are embracing IoT in agricultural system. Not only IoT, drone is also becoming a major technology device in the area of agriculture. What are the common network security challenges we are facing? Strategies for implementing a better network security in the area of agriculture, IoT security solutions, future trends, and we will have some hands-on sessions also in some of those interesting AI tools. And before we start the session, let's go through a interesting video.
Groceries, the
Is the audio is the
food we
audio
buy off the
hearable now?
shelf, of
Can you guys hear the audio?
Yes, sir.
Yes, sir.
Okay.
course, it's all cultivated and grown on farms. And if we head to India, 50% of the workforce are employed in agriculture, and a growing population, now 1.4 billion, are dependent on the crops produced. But traditional methods are now making way for new technology that promises to make farms more efficient, productive and profitable thanks to artificial intelligence. Archana Shukla reports.
For generations, Indian farms have been sown and tilled only with traditional know-how. But some, like Nitin Patil, are trying out something different. With sensor devices on his vineyard that check weather and soil health and uses artificial intelligence to figure out when to water the crops, add fertilizer and tackle pests. Nitin then receives a precise advisory on a mobile app.
This vineyard where we are now, it has no groundwater sources, and we are growing these wines with the water that we purchase from outside tankers. With the help of this AI data, we are now able to irrigate them only at the crucial stage, and that's helping us to save around 50% of the water that they actually we used to give before.
Built in India's Silicon Valley, Bangalore by startup Fossil Agritech, the service has led to a near 25% boost in productivity on crops like grapes and guavas. Informed decision making is only one part of the solution to improve productivity, but weeding out inefficiencies in the existing age-old agricultural practices is also crucial. AI-powered robots offer a solution. This one is equipped with precision cameras that scan the ground in real time, programmed to avoid wasteful spraying.
The way spraying is done in India is on an acre level. And our mission is to boil that down into a plant level decision making. Just by spraying only on the plant, we are seeing a 56% savings.
Improved rural digital connectivity and government support for agri-tech startups has pushed farm innovations. But even now, just 2% cultivators use tech in farming.
We really need to enable the digital public infrastructure. And second is going to be public-private partnerships. India will always be resource constrained. We possibly are perhaps lowest in the yield level. We possibly are pretty much constrained on finance and insurance services for the farmers. And that's where the gap needs to be filled up with AI.
Data-driven agriculture promises profitability, but will need considerable time and investment to reach majority of India's farmers. Archana Shukla, BBC News, Bangalore.
Can you please just hear me out? No, I'll work.
Okay, so did you guys hear some interesting advantages of from this video? There was two inferences in terms of resource efficiency. Did you guys observe that there was a couple of points the specialist mentioned? There has been some in terms of using the AI sensors and tools. There has been a couple of advantages they mentioned. Did you guys observe what they are?
Yes, we did.
Yeah, maybe. Maybe you want to share. Okay. One is that basically, like the first user mentioned that they are buying water from outside area, and then because of those AI data, they are precisely able to say like when exactly the water level in the soil will go down below 50%, and then they will soil the or irrigate the plants, which actually results in 50% savings in water. Another user mentioned that they are actually using a camera-based sensor machine to spray water, which actually locates the exact position of the plant and sprays exactly on the plant instead of covering a larger area, thereby resulting in 50% water conservation. So, I mean, like just from this 2 minutes video, we are able to actually identify two ideas or concepts that actually helps to save water. And there are actually plenty of ideas or technologies available in terms of measuring the air precipitation, water like soil precipitations, and other technical factors that allows to be moderated or and helps to manage the resources efficiently. So these are some of the key takeaways from the videos. So as we could see, right, so agriculture is being reshaped with the advent of new sensors, IoT devices, and also drone-based technologies, which is completely reshaping the way people look at farming and then ways to improve the productivity and production. Yeah. Okay. Coming back to the slide. Okay, so this is what we saw. So basically, so the key, the advent of the new technologies is actually like the IoT devices, drones, and the AI-driven analytics, like increases the efficiency and of the resources and how we go about farming. Understanding IoT in agriculture. So this is another way. Actually, so basically some of those key areas what we can look, right? The smart farming solutions, which actually helps you to improve the soil health, crop conditions, and predict weather patterns, enabling farmers to make informed decisions. I mean, basically, like these IoT devices actually generates a lot of data that needs to be analyzed in a research facility. That's why we need a lot of data collection and analytics tools as well. And precision farming is also one of the latest the farming techniques that is actually helps to build a sustainable agricultural practices. We will see a couple of more videos that, regarding this smart farming and also how precision farming can help to improve sustainable farming mechanisms.
So have you played the video?
Yeah, it's playing. Can you guys see it?
No, no.
Is it? Oh, okay, okay. Oh, okay. 1 second. Okay, sorry. Okay. Okay, are you guys seeing the screen now?
Yes, sir.
IoT security,
Is it playing now? Is it visible now?
Yes, yes.
challenges and solutions. IoT security challenges, vulnerabilities in devices. IoT devices often have limited processing power and memory, making them vulnerable to cyber attacks. Inadequate protection. Many IoT devices lack basic security features such as encryption and authentication, leaving them susceptible to breaches. Network security. IoT devices are often connected to the internet via insecure networks, making them easy targets for hackers. Solutions to IoT security challenges. Implementation of encryption. Encrypting data transmitted between IoT devices and networks can prevent unauthorized access and ensure data privacy. Strong authentication. Implementing two-factor authentication and biometric security measures can enhance the security of IoT devices. Firewall protection. Installing firewalls on IoT networks can help monitor and control income. IoT security, challenges and solutions. IoT security. strong authentication, implementing two-factor authentication and biometric security measures can enhance the security of IoT devices. Firewall protection. Installing firewalls on IoT networks can help monitor and control incoming and outgoing traffic to prevent cyber attacks. Regulatory compliance. Adhering to industry regulations and standards can ensure that IoT devices meet security requirements. Automation and integration. Using automated security solutions and integrating them with existing systems can enhance the overall security of IoT networks. Remote monitoring. Implementing remote monitoring tools can help identify security threats in real time and respond proactively. Conclusion. As IoT devices continue to proliferate across various industries, ensuring robust security measures is essential to protect against cyber threats.
Okay, so I just want to highlight here, right? So basically, network security in IoT is a very critical and very sensitive issue, because like IoT devices are some of the most vulnerable devices that are exposed to the internet, just because they are very elementary devices that connects to the internet without any two-factor authentication or basic authorization. They directly connect to the internet, which will result in potential easier hacking routes actually. So securing these IoT devices, the way communicate to the internet backbone is really very critical. That's why following a security framework in integrating these IoT devices to data framework is extremely important. Because in current scenarios, basically like the small small level agricultural farmers are, if they are using these IoT devices, getting these devices compromised may not have a bigger financial impact to them, but if there are bigger players or B2B players implementing these kind of IoT solutions, security is a very critical aspect of IoT implementation. So that is something we need to take note when we are talking about IoT based implementation. Okay. And next we will see about how precision farming is going to be the next the big thing, and how it can improve the productivity and also the productions as compared to the normal or the traditional farming techniques. So can you guys see the screen?
Yes, sir, it's visible.
Okay, so we'll see about precision agriculture.
Years, the agriculture industry has experienced a transformation unlike anything seen before, fueled by technology, data, and sustainability. This revolution has a name: precision agriculture. Precision agriculture, or precision farming, is a modern farming practice that uses technology to monitor and manage variations within fields. Instead of treating entire fields as uniform, precision agriculture focuses on optimizing production by taking into account the unique needs of specific areas. The goal is simple: increase crop yields, reduce waste, and promote environmental sustainability. Precision agriculture leverages a suite of advanced technologies to achieve these goals. Let's look at some of the most important tools driving this shift. GPS, Global Positioning System, and GIS, Geographic Information Systems, are at the core of precision agriculture. GPS allows farmers to accurately map their fields, while GIS helps analyze spatial data related to soil properties, moisture levels, and crop health. This information allows farmers to make data-driven decisions about where to plant, fertilize, and irrigate. Remote sensing through satellites and drones provides real-time data on crop conditions. Drones equipped with multispectral cameras can detect subtle changes in plant health, pinpointing areas that might require extra care. By identifying problems early, farmers can take proactive steps to manage crop health before issues spread. Internet of Things, or IoT sensors, are now an essential part of modern farms. These sensors track everything from soil moisture and temperature to nutrient levels. By collecting this data continuously, farmers can optimize water and fertilizer use, saving resources and enhancing plant growth. All of this data is valuable, but it's only useful when properly analyzed. That's where big data and artificial intelligence come in. Using machine learning algorithms, AI can analyze large data sets to identify patterns and make predictions, guiding farmers on the best practices for planting, watering, and harvesting. So, what makes precision agriculture so impactful? Let's break down the main benefits. First, precision agriculture increases crop yields by optimizing input use, from fertilizers to water, creating the ideal environment for crops to thrive. By targeting resources only where they are needed, farmers can reduce costs while ensuring that each plant receives what it requires to grow healthily. Second, precision farming minimizes environmental impact. Excessive use of water, fertilizers, and pesticides contributes to pollution and soil degradation. By using only what's necessary, farmers reduce runoff and promote soil health, ultimately fostering a more sustainable ecosystem. Precision agriculture isn't limited to a single type of crop or farming method. It's versatile and adaptable, with applications in various crops and agricultural practices. For example, in row crops like corn and wheat, precision techniques can be used to manage irrigation, pest control, and fertilization. In vineyards, precision agriculture helps monitor vine health and grape quality, producing a higher quality product with minimal resource use. While precision agriculture offers many benefits, it isn't without challenges. Implementing these technologies can be expensive, and they require training and technical support. Farmers in remote or under-resourced areas may struggle with access to necessary equipment and reliable data connectivity. Additionally, data privacy and cybersecurity concerns have emerged as farms become more reliant on digital platforms. Despite these challenges, the future of precision agriculture is bright. Advances in robotics, AI, and sensor technology continue to push the boundaries of what's possible. Farms of the future could be fully automated with self-driving tractors, AI-driven pest management, and real-time data collection feeding directly into predictive models. As precision agriculture evolves, it promises not only to improve food production efficiency, but also to play a key role in solving global challenges like food security and climate change. Precision agriculture represents the intersection of science, technology, and nature. It's a powerful tool to meet the growing demands of our world while respecting the environment that sustains us. By leveraging data and technology, farmers around the globe are not only feeding the world, but also preserving it for generations to come. Thank you for joining us on this journey into the world of precision agriculture. If you found this video insightful,
Okay. Okay. So anyone working on precision farming projects? Anyone coincidentally working on precision farming projects as part of your research or okay. Okay, so basically, so you guys have seen how precision farming is actually going to reform or change the way farming is going to be done in future. It can monitor the soil conditions, crop health, weather patterns, and sensors and drones enhances efficiency, allowing for targeted resource usage so that you can reduce water and controlling pest usage and optimizing the yield. So basically, so some of those key advantages of precision farming in agriculture is increased efficiency, not only in terms of manpower, but also in terms of productions, in terms of the resource management, resource utilization. You saw in some of those usage of these IoT devices helps to save 50% of water in certain cases. So it helps to save, conserve resources, and also it helps in better crop monitoring. So as I mentioned, right, so basically network lapses in IoT devices is one of the key issues because these devices are largely unsecured devices which works without any primary authentications. There are, even if there are authentication, they are weak authentication. So basically, there are no two-way process. So all of these will result in a potential vulnerability or a cyber attack to the main network backbone. And then these lack of knowledge or proper training will result in outdated softwares or firmwares, resulting in further issues for these devices as largely as in terms of growing cyber threats. So these are some of those major concerns in terms of using IoT devices in the agro space. There will be growing potential risk of cyber threats, and then there can be security breaches, thereby calling for robust security measures actually. So the consequences of, security breaches will result in data loss, disruptions on operations, and as I mentioned, if these are bigger companies, B2B companies, then there are financial implications and the losses as well. Strategies for network security. So basically, what we have to do is that in terms of these light of these concerns, what we have to do is a better device management, those software updates. We should follow a strong authentication protocols and then have these the software updates regularly done. We should have a regular security audits to ensure those the devices are properly maintained and managed, and then there should be appropriate training for the staffs who are actually handling those devices on the field, so that they change passwords, regularly do the software updates, and keep these devices secure from any breaches. So the effective risk management in terms of these technologies is basically identifying the potential risk and then assessing any potential impact, and also coming up with some potential response and contingency plans actually. And basically, I just want to take this opportunity to also introduce to you that CyberVault, in collaboration with LearnLike, we are working on the next generation firewall, which is called as CyberLabs, which is going to be available in the market very soon to specifically handle these kind of security issues. So these firewalls will not only be available to the corporate sector, but also to other sectors who wish to set up infrastructure which are securely protected. Even for agrotech, if they want to securely protect their IoT devices, like we recommend to use a standard firewall in the market, or we can assist them to integrate our firewall solutions into their IoT network. So basically, like how we can protect these IoT devices in the technology landscape moving forward. We have to use strong encryption techniques, like as part of their firmware, and then use increased AI-based anomaly detection systems that can predict any potential security breaches, and also use secure communication protocols. And one area is that we can even use blockchain as a mechanism to protect the data integrity of these IoT networks actually. So future trends in network security. So machine learning will also play a key part in improving the network security of these IoT devices, and the blockchain, as I mentioned, will also be a key factor for ensuring the data integrity of these devices. And then the next generation of IoT devices will be using more advanced encryption protocols and a security mechanism that will make it foolproof. So basically, what the challenges that we are looking at, even if the technology landscapes are changing, is that basically like we can expect new threats in, even for these technologies, and there can be regulatory changes also that will impact the way these IoT devices are connected and regulated. And then like we have to be mindful of the key implementations of cybersecurity in this agro space. Like there will be increased demand for embracing cybersecurity in the agro tech space. Yeah, so what we have to do as key stakeholders, we need to look for continuous improvement and also collaborate with the different technology specialists to handle the growing technology needs. And then farmers, if they are not tech enthusiasts, technology providers and institutions can collaborate and work with these, like ground level people to improve their understanding about how to use these devices so that they are better prepared to have a safe working systems actually. So these some are some of the key points. So basically, like you need to continuously improve and adopt the new technologies, and also have to understand and how these devices work, and collaborate with the different technology providers to be a successful ecosystem, agricultural ecosystem. Okay, so basically today's presentation is a bit short. So if you guys have any question regarding that, so I have also a couple of AI tools to present. So we will go into those topics actually. So any questions that you have wanted to ask regarding yesterday's sessions and the use of IoT sensors, drones in agriculture. Any questions before we jump into another tool? So there was a question earlier. Sorry, do you want to repeat that question?
Sir, am I audible?
Yes, ma'am, you're audible.
Sir, what will be the cost benefit ratio of adapting this IoT to the marginal farmers actually? When we speak about the larger holder farmers, it is possible we can go for using out the sensors and we can use smart irrigation, everything we can do it. But when it comes to smaller hold farmers, what will be the benefit actually in terms of cost?
Okay. Okay. So basically, I believe that so the cost we cannot see it in terms of the benefits, right? We have to see it in terms of the increased productivity, ma'am. So we have to look at two aspects actually. One is basically these IoT devices are not very expensive actually. So it is nominal in the market. So there are products available in different price ranges. So one point is that it is definitely not costly and it is affordable. So and the other two benefit is that, right. So you have to look at the return on investment. One is like you are able to increase the productivity. So there is definitely increase in returns for the farmers. Another is that like when you are using technologies like this, there is consumption of water. Say for example, you are saving on water, you're saving on pesticides. So all these things like there is conservation of resources also. So you have to look at three dimensions actually. So the one is basically these devices are not very expensive, so it is affordable. So it is basically something you have to look at long term and make a one-time investment. And second is you are actually getting a better yield and also saving on this water. So it will save on like your electricity bills or water bills. So definitely there is a bit of saving. So definitely it is worth considering to make this one-time investment to look at long-term benefits and returns.
Thank you, sir.
Any such AI tools for precision farming? So are you looking? So basically, so there are tools available, ma'am. So but largely what I see is that like people actually do bespoke development. So we even get requests to build some products for the agri sectors, but largely there are not much. Yeah, so this sector is not largely in an advanced stage, at least when it comes to SaaS-based products or AI tools. But there are one of the bespoke developments like people try to build for their own use. At least bigger players, they are trying to build it to address their internal requirements. But largely, there are not such very targeted tools at the market as of now. But if we have the data right, if we are able to collect this data from these sensors or IoTs, we can definitely use this. So we are going to go through that tool later. So we can feed the data into any analytics tools and we can get the required inferences or insights actually. So all we need is the data. So the tool, a lot of tools are already there in the market to actually to convert that data into a meaningful insights actually. But when it comes to precision farming, there are no specific mobile apps or tools available. It's targeting this segment alone.
Thank you, sir.
I think for IoT soil sensors, I have seen people using Arduino as a primary sensors to integrate for measuring soil sensor precipitation levels. People are using Arduino. And Raspberry is also a popular device that has been used for many IoT devices. So it's Apple to orange kind of comparison map. So it is basically choosing whether you want to buy like basically a Oppo phone or a Vivo phone. So both are running on embedded Linux. So it's basically based on choice and preferences. Any other questions? And yesterday there was a question. Priyadarshini ma'am was asking like, how does people from the rural areas get benefited from for better healthcare? Right, there was a question that was asked yesterday. So I mentioned that basically that remote monitoring solutions can actually provide equal healthcare offerings for all, not only urban people but also rural people. But there is another point I want to add. Just like how companies are doing corporate social responsibilities, right? Institutions should also offer some kind of rural medical camps as part of your relief or as kind of social corporate social responsibility for these rural villages, remote villages, so that even these rural people will get access to better medical care. So another answer is that I request all these institutions to come together to offer free medical camps so that these rural people also will get benefited. Okay, any other questions? Okay, so if there's no further questions, I will actually jump into a couple of. Okay, there's another question. How can detect contaminants like heavy metals, uh, 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 pharma pollution, contaminants in soil using IoT and AI tools? Okay. Um, I take this question for answering it later because right now I do not know any IoT devices. But if we can find some ways to actually identify the ingredients of the soil, we are able to do some tests, and if we are able to identify the ingredients of the soil, I think then that it is possible to feed that data to AI tools to identify any potent pollution level or contaminants actually. So the key is to identify the ingredients of the soil, and then with that data, I think we will be able to identify the pollution level. So right now, I don't know any IoT tools if it can get this information, but If laboratory tests can give those data, then definitely we can identify the contaminants in the soil. Okay. All right. So if no further questions, I will go into another tool. Okay. So today what we are going to see is that the quadratic HQ. Okay, one second. I will see share that screen. Can you guys see my screen?
Yes, sir, we can see.
Okay. So you can take note of this links app.quadratichq.com. So this is one of the also tools that helps you to do analytics. So I will share that link. So Thiago sir presented some time back that we are able to use data wrappers to generate dashboard screens, right? So basically, this actually helps to infer analytics using the same data, actually. So can you guys see my screen? It's visible, right? Okay. So what I did is that, right? One second. Okay, can you guys see my screen now? Is it visible? Hello? Is it visible?
Yes, sir.
Yes, sir.
Okay, fine. Okay, I am actually like this is actually a tool to infer analytics, right? So basically, I'm going to upload the same data that Thiago sir was using. So I'm going to import this same India state annual rainfall, but only change is that I'm only using the 2024 data sets here actually. So I have removed the other data here and only using the 2024 data from all over India. So if you can see here, right? So the tool is actually loaded that Excel data into this sheet, and then there is a chat GPT kind of a prompt, right? That asking me what I should do with this data. So I will actually tell it to build a chart from this data. I will just click this. Okay. So now it is actually accessing the data and then building a data set for me. Actually, so it is converting that table into a rainfall chart. So if you see here, right, so basically it has plotted the average rainfall by state actually. So looking at the data set, right, so basically like you can see Goa and Andaman and Nicobar Islands and Tripura have recorded the major rainfalls of close to 3,000 to 400 millimeters of rainfall. So I can even ask it to add a line chart for rainfall trends. Okay, so I can ask it to build a. So basically, like, so if you look at this, how we have to interpret in this, those in this color range is actually having higher rains in the month of July and August, and then the one in the lower color is actually like is from Jan Feb, so it is increasing. So the basically the peak rainfall has been in the period of like June, July, and August during the monsoon seasons actually. So so using this data, right, you can actually make plenty of inferences actually, and then you can also generate the top three states by rainfall. Okay, so if I want to generate the top three states, so basically, okay, so it is Goa, Tripura, and Andaman. So so it is actually recommending, and then also based on my query, right, it is building the Python code on the fly, and then it is turning the data into insights actually. So once you have the data, right, so you can use tools like Data Wrapper to turn it into an insightful visualization. And then Quadratic HQ is another platform where you can turn those data into insightful analytic reports actually. And I also used the same data wrapper to actually generate crop distribution. Actually, since today's topic is agriculture, so I also used the same data wrapper to generate crop distribution in Tamil Nadu based on some sample data from ChatGPT. So, looking at this data, right? So you can actually see that. So we are able to generate for Tamil Nadu. So like, what are the key crops that are grown? So Dharmapuri, mango, ragi, millets, and then you go to Salem, it is mango, ragi, paddy, and then if you go to Tirupur, it's mostly cotton, and then if you go to Theni, it's mango, banana, grapes. So Tanjavur, it is mostly coconut, sugarcane, Nagapatnam, paddy, coconuts, and Virudhunagar, paddy, cotton. So all this data are based on some sample data uh, from ChatGPT, which I took it as a reference, where you can use the same steps provided by Thiago sir, and then convert these data into these visualization reports. So you can also actually use this for any kind of visualization, not only for rainfall or not only for this kind of agri data, but for even for any other visualization data representation that you may want to infer from the maps actually. Okay, so this is something I wanted to share in addition, so that so basically you can actually play around with these tools, and then come back to us if you have any questions. And if you want a more detailed session on these AI tools like the Data Wrapper or Quadratic HU or any other AI tools, then so you can get in touch with Deepak sir or myself. So we can have a separate session to help you to learn these tools and see if this can help you to improve your day-to-day work and presentation requirements. Yeah, so this is a couple of things I wanted to share today. So I think that's all for today's sessions. And do you want to explore anything further, or do you have any other questions regarding these tools? Actually, any questions regarding these tools, or if you have any data you want to give, I think we can right away use it and also do some hands-on as of now. So we have time. So if you want to uh, have any sample data that you want to try it out now, we have time. We can do it now.
Participants, you have any suggestions or any queries? So I think the tools that we'll have to sit and work on
Okay.
that basis. Maybe if we come across any issues, we'll get back to you.
Okay, so I think I already shared the links, right? Okay, so okay, I will share it again. Okay, so basically, like you guys can actually work on it and then come back to us if you have any questions. Actually, so I will share that link here. So okay. It's a very useful tool actually. So you guys can try it. It will be definitely very useful to generate very insightful data very quickly. Actually, you just need to even if you don't have a data expert, like you can even to connect to any live database and then readily download and then generate the data on the fly. I'm sorry, I do not have any live system to show. Otherwise, I would be able to show more real-time data. Essentially. Yes, that's correct. It's app.quadrantHQ.com. So there is one question. Can we integrate different types of sensors into one sensors like combining the pH, NPK, moisture? Sorry, Dina sir, I am not a sensor guy. So I will get back to you on this. Yeah. Okay.
So I think we can wind up the session now.
Okay, sure. If there are no further questions or clarifications, I think we are good for today.
Janaranjali ma'am.
Sir? Yes, ma'am. Yes, ma'am. Thank you very much, sir, for that wonderful session. As we come to the close of today's proceeding, I now invite Dr. R. Mognapriya, Associate Professor, Department of Biotechnology, to propose the vote of thanks and express our gratitude to all those who made today's session enriching and successful.
On behalf of the organizing team, it is my privilege to propose a vote of thanks for today's session of our Atal Online Faculty Development Program on AI and Cybersecurity for a Sustainable Future, Innovations in Health, Agriculture, and Smart Cities. First and foremost, I extend our heartfelt gratitude to today's distinguished speakers, Mr. Tyagarajan Palanisamy, Learn Like Coimbatore, and Raj Babu Gunaseelan, Cybervault Singapore, for their enlightened sessions. So, your knowledge and perspectives are truly enriched our learning journey. I also take this opportunity to thank our respected management, principal, and coordinators for their continuous support and encouragement in organizing this FDP. A sincere thanks to all our enthusiastic participants for your active involvement, interaction, and commitment, which makes this program meaningful and vibrant. With this, we bring day 3 to a close. We look forward to your participation tomorrow as we continue our journey of learning and innovation. Thank you once again.
Thank you, ma'am. With this, we conclude today's sessions of the FDP. We extend our heartfelt thanks to our distinguished resource person and all the participants for your enthusiastic involvement. We look forward to your active participation in the upcoming session. Have a wonderful evening ahead.
Thank you.
Thank you.